Hello everyone, welcome back to this new episode. We're going against a security company and we're trying to hack it. We've already gained access to the server hosting the website as Jimmy. Before that, we were authenticated as Martin. So we are about to compromise the entire server and get root. Let's get started. All right, it seems that we have an interesting script here, networker. Its SUID bit is set and it's owned by root, meaning we can run it as root. Now the question is it vulnerable? Let's check it out. Before that, I'm just going to check real quick on the bash history, just to see if there is something interesting. wget localhost doesn't seem really interesting here. What about bash rc? Same thing, nothing that pops up. All right, finally, just to check the profile, I'm going to use less. Just don't want to get my terminal cluttered. And we have nothing really interesting here. All right, anything under .ssh? We have authorized keys, and that's because we've created that file. Okay. So now it's time to poke around with this networker. First of all, what is this networker? Is it an ASCII, an ELF? In this case, it's an ELF 32-bit, and it's dynamically linked. We're going to see why this is important later. And if we run it like that, we have some output, SUID. We have networker 2.0 with what seems to be the results of ifconfig, and then a ping command to localhost, and then echo Linux tool version 5. Do we have like any input that we can provide here? Doesn't seem to be evaluated. Okay. Do we have strace? Nope. Well, we have strings. Do we have ltrace? Nope. So I can't run it and see what are the different functions that are running behind the scenes. So I'm just going to perform some light static analysis. So using the strings, actually I need to provide it with name of the script, networker. So we have a bunch of strings that are common for an ELF binary. We have the libraries that are imported here. We have a call to put in C, printf, system. What else? We recognize some script strings, networker 2.0, and we have what seems to be the exact commands that are running. sbin if ifconfig, bin ping with localhost, and echo Linux tool version 5. What I notice here is the fact that these two are using absolute paths, while the echo here is using a relative path, like it's not using any absolute path whatsoever. And since this is a script that is running as root, then this might be a vulnerability. Essentially what we can do is let's print the content of $path environment variable. So whenever we run like echo hi, the system will look for the echo script or binary inside this folder. Then it will go to this one, and so on and so forth. So what I can do here is define a new value for that environment variable. So the first folder I wanted to look for the echo under is home Jimmy. And then I will append the value of the old path. So that way we have $path that contains our new value. I'm not sure if this is going to work because this will run as the root context. So in this case, not sure if this value of path would be taken into consideration, but let's try. We can simply create a script called echo, vi echo. And just to test, I'm going to run ID. Why not? Well, maybe we can do an ls-ali to generate some output, and then we're going to change it to an executable. And if everything goes well, networker will try to run echo. Echo is here. It's going to be run, and hopefully we will see the output of ID and the listing of the current directory. So let's cross our fingers. Networker, run it. And do we see here anything interesting? Oh, bummer. Nothing. It's the same output as before. So this means that this didn't work. Now, if we cannot hijack execution using this trick, what else do we have? So if we go back to the strings output, you can notice here some libraries, but also a call to some C functions. Printf, putString, system. So one of the ideas to hijack execution is to hook into those functions. For example, let's target putString, or maybe printf. Printf would be better because we know for a fact that it's going to be used somewhere here to print those strings. I mean, putString also can do that. And so to hijack the execution, we need to create a file that is going to be compiled into a library. To do that, I need GCC. What do we have here? Oh, we don't have GCC. We have haha, nope. Okay, it's not a problem because we can use our own GCC here. Yes, we have GCC here. So we need to create our exploit here and then compile it as a library and then transfer it to this box and try to execute the attack. So this is simply what we can define here. We replicate the same signature as printf. It accepts a pointer to a string, and then instead of printing the content, we actually just go ahead and run system. That would copy bin bash into temp.root and change its SUID bit, and that way we can run it as root. So we need to compile this. So that would be gcc exploit. I've just copied this string from a resource on the internet, name it exploit.so. Now, if we run file on that exploit.so, you can see that it's a shared object, but this is a 64-bit because I'm running on a 64-bit machine. So what I can do is just add M32, and that way I have a 32-bit LSB shared object. This is what we're looking for. So let's copy this over to our machine. Now, do we have wget here? Localhost. Oh, nope. Okay. What about curl? Same thing. That's not a problem. We can still copy it. It's a small library, so exploit.so and base64 encode it. This might seem like a large string, but it is not. It's relatively small. Copy it and let's paste it over. Let's call it base64 and paste in our base64 encoded library. So simply just run base64-d to decode it. The file is called base64 and I'm going to put everything into exploit.so. Now if I run file exploit.so, I should get back the same thing, ELF 32-bit. Now, in order to hijack execution, there is a special environment variable called ld_preload. And this one will contain our library. So whenever we run networker, this library would be loaded, and then we will have theoretically a new definition for the printf function. If we run that, we see nothing really that changed. This is a bad indication. And if we ls temp root, we see no file named root. That's a bummer. Remember, our exploit is trying to copy bin bash into /temp whack root. So it seems that we are hitting a dead end here. We can't hijack execution. I'm not sure if there's any ideas that we can follow here to exploit this networker script. I start to feel like the author has put it here specifically to throw us off. So let me know in the comments below if you have any ideas and if you've been able to exploit this networker script to gain remote code, to gain privilege escalation. In the next video, we're going to go back, perform more enumeration, and see if we can find our way using a different approach. Make sure to subscribe and hit that ring bell to receive a notification when the next video is live. As always, stay curious, keep learning, and go find some bugs.